Hello everyone, can you hear me? Hopefully the audio is okay. This is a new setup. So finally my Mac Mini has come in, and that means that we can stream in 1080p and we can also compile on Xcode simultaneously. How's everyone doing? I see some familiar faces already. Where are all you guys from? Now, before we start, I do have to give you guys some context about what this weather app is all about. Now, I'm not sure how many of you guys are part of our Code Crew community forum. Let me just make this text a little bigger. So hopefully it's really easy for you to see now. It's really huge for me though. Argentina, Algeria, Brazil, awesome. I love to see people from all over the world. This is amazing. Yeah, so I bet you a lot of people here in the audience must be starting out as a beginner, brand new. I have to say that this app is a little more intermediate than, it's not, intermediate, but I would say in order to follow it properly, you would need to know at least the basics. But don't worry, I'll try my best to go slowly and explain it step by step. And a lot of these streaming and coding type of events are going to be pretty messy, right? It's not going to be like the prepared videos, tutorials that I would actually film and take you through step by step. So you're going to see the messy process of coding here. Now, if you are starting brand new and maybe you haven't gone through the SwiftUI basics or anything like that, I would suggest you to just go to my channel, youtube.com/CodeWithChris, and go through this beginner playlist right here. And would also help for you to go through another video that I have. Is it Swift API? Yeah, this one right here, or any of them for that matter. Because the big exercise for this weather app really is to connect to the weather API here to get the data, and then to parse that data, and then to display it in the app. All right, so we'll get started shortly. UK, India, England, Saudi Arabia, awesome. Germany, hello. I was waiting for this for a long time. Well, it was only a matter of time before this new Mac came in so that I can actually build on Xcode without killing the stream. So I've been using this new Mac Mini for about a day because the monitor just came in yesterday, and everything's a lot faster, I'll admit, but yeah, launching the simulator, compiling code, it's super fast now. All right, so we'll get started. Again, I want to give you guys some context about what this is all about. So in our Code Crew forum, which is at codecrew.codewithchris.com, you go here. About every month and a half, we issue out a community app challenge. So this is a chance for everyone to try and build something, because through the process of learning, you don't really get things to sink in until you start practicing. So even if you go through my tutorials and you watch, all of these 14 beginner lesson videos, it's not going to do anything for you unless you launch Xcode and you try to do some of it. So we started these routine community app challenges to encourage people to take part and to try to build something on their own. And even if you can't finish building it, you'll still learn a ton. Shout out to Warcard. Yeah, I did get the M1. This is an M1 Mac Mini with 1 terabyte of hard drive space and 16 gigs of RAM. So far we've done 2 of these app challenges, right? We've done the weather app challenge and we've done the stock tracker app. And actually, you guys, I've showcased your apps here. So this is the stock tracker app challenge that you see here. and there was a weather app one, which we did a while ago. And I don't know if some of you guys are in the chat right now. If you did the weather app challenge, please shout out. So props to you for doing that. All of the community's weather apps looked amazing. And so today, we have about an hour, and I haven't done this weather app yet because we usually get the Code with Chris interns who come in here to work on these app challenges as a way to ramp up and learn SwiftUI and Swift, because a lot of them come in, they don't have that experience. But because they have the computer science background, or they know maybe Java or whatever they learn in school these days, right, they can get up to speed pretty quickly. Yes, Mark, you did the weather app. It looked pretty good. One thing to note as well, even though there were specific dates for this challenge is still open. So after you watch this video, if you get inspired, or maybe there was a part you were stuck at that this video illuminated for you, you can definitely go back and do this app challenge. Or even if you haven't started it, you can start it right now, and you can request to have this forum badge. In our forum, you can earn badges. So it's kind of like a fun little reward. We're going to come up with a new app challenge in a couple of days, and there'll be another badge that you can earn for that. All right, so let's scroll down and take a look at the requirements, because like I said, I haven't actually done this before. Now, I did take a look at the API last night, and it's actually a good thing that I did, because although this API is free to use, it's a single call API. You pass in a lat long, so just like a set of coordinates, and it returns to you all of the data that you need. So current weather and conditions, as well as hourly future forecast. It's a good thing that I created my API key last night, because it did take a few hours for it to go live and take effect. And I was confused at first because I wasn't able to make this API call even though I had an API key. So if you're brand new to Swift, you're brand new to app development, oftentimes apps will be, unless it's like a calculator and it's sort of self-contained, most apps will fetch data from somewhere to display within the app. And an API is just an interface to another platform or another data source that you can make network calls to and requests to, and you pass in a certain set of criteria along with an API key, which usually identifies who you are and identifies if it's not free, that's their way to identify how many requests you're making, because usually it's limited. So you make these requests to the API, and then you get data back, which then inside your app, you can unpack. It's known as parsing, if that's new to you. And then you can go ahead and display those pieces of data on your UI. So in this particular live stream, in the hour that we've got, we'll probably take a look at this API together. I've already signed up for an API key. We'll do some test calls. I'll show you something called Proxyman, which is a tool which will allow you to take a look at the traffic going in and out of your iOS simulator so that you can debug any issues. And we'll probably display some basic information on the screen. Now, there won't be any fancy UI. So if you saw Mark's tweet earlier about watching me build a complete weather app, I'm thinking that in this hour, we will probably be able to make the API call, parse the data, get some data on the screen, and then maybe in a follow-up stream, we'll construct the UI. Not to mention that I have no idea about what to do for the UI right now. Awesome. I'm glad to see that some people have done the app. Football app with all the latest games. Awesome. Yeah, we're going to do a sports statistics app as a community app challenge soon, so you might be interested in that. Okay, so let's get started with this API. It's pretty simple. If you take a look at, this is an example. Should I make this, let's make this bigger. That's easier to see. Okay, so this is the URL, and we can even hit this in our browser, right? This is a free API, so all you need to do is create an account and you get an API key. Now, normally you'd probably want to keep these private, especially if you're, well, whether they're free or paid, you probably still want to keep it private, because if someone else gets your API key and uses it, they're basically using your usage amount. Now, for the free API for this weather call, this weather API, they limit you to about 1,000 calls a day, which for our purposes, for learning, is more than enough. Right, so you can see here I created a second one because this first one wasn't working, but it really was just that it takes a few hours for it to turn on. Hello from Vietnam. Hello, hello. Okay, so this is what we're gonna do. We are going to just open up a new browser, and we're gonna paste that there, and we're gonna replace the parts with the appropriate data. So you can see there's a lat, there's a long, there's a part, and there's an API key. Now, most APIs, I think all APIs will have some sort of documentation telling you what these parameters are and how to make the calls and what sort of data types that these parameters should be. So if you take a look down here, parameters, these are required. So you have to supply these into your call right here. You need the app ID, which is essentially your API key right here. So I'm just gonna take this and I'm going to replace it right here. And then you have your coordinates, latitude and longitude, and these are required as well. So for this demo, we're just going to pick a location. And do you guys have a location, a city that you guys want to see? Too bad I didn't, first one to type in a city, we'll use that city. Too bad I didn't do any sort of voting thing. If I implement something from Streamlabs, which is the streaming software that I'm using, we can vote between two places and get the chat to vote. All right, let's see what we got in the chat. Beirut. All right, that's what we're gonna use. The rest of you guys, you gotta be faster next time. All right, so we're gonna use this. This is the lat, right? And this is the long. Now, if we take a look at the last parameter that we need to do, which is part, let's take a look at what that means. This exclude part. So this is optional. That means that we could run the API call as is. We don't need this parameter, but it does allow you to exclude some data from the response. So if you don't care about alerts, you don't care about minutely or hourly or daily, you can exclude that, and that saves bandwidth. And that it's generally, you don't want to grab everything when you're making calls. Grab only what you need. So we can just put something in here minutely. Maybe we don't need minute by minute data, so we'll put minutely in here. And I'm sure you can put multiple. Comma delimited list without spaces. We could try that. Alert. I don't know if we'll have to encode that. Okay, so this is the response that it gave us. Just make this bigger. Please explain the endpoint as well. What could be the endpoint here in open weather? So the endpoint, this is the endpoint right here. They have different endpoints for different pieces of data. This one call endpoint is just a single API call which returns like all the weather data that you would need. But if you want historical data, for example, I think, yeah, there's historical data. So I guess you'd have to pass in a time for when you'd want your weather data for, and then also the coordinates. So there are a couple of different endpoints here, but the one that we're using today is, where are we here? this one call endpoint. Okay, so this is our data. Now, if you haven't learned Swift before, this will be kind of hard to understand, but we'll do our best here. So you can see that it all collapses nicely. It's like a hierarchy of data, right? And each piece of data has a label and a value. So this is also what's known as a key. So you can see that this is exactly the location that we passed in, right? It's telling us also the time zone offset, and any good API documentation will also tell you the data that's returned. It'll explain to you what those pieces of data are, because sometimes it can be pretty confusing. So if we go down, example of API response. So this is kind of what we got here. And if we want an explanation of some of these values and keys and what they mean, if we keep scrolling down, it'll tell you fields in the API response. So I really like API documentation that is so easy to read and so clear like this. So for example, shift in seconds from UTC, right? That's perfect, because if you look at this, it's hard to tell what that number is, right? But this documentation tells you exactly what that data means so that you can do something with it. Okay, so in here we have current, which represents the current weather, I'm assuming, and we have inside a group of data. And we have, so you can collapse this. So all of this data right here is related to the current weather. And DT, this is a big number. I'm going to assume that that means date time. Yeah, DT here, current time Unix UTC. So we're gonna have to do some conversion, right? And I'm assuming this would be number of seconds. Sunrise, like time of when the sun rises, time when the sun sets. Temperature, right? This is a big number, which I'm not quite used to. So let's take a look at this. Temperature, units default is Kelvin. You can do Celsius, Fahrenheit. How to change the units used. So let's click this, and you can see here there's an additional parameter that you can supply called units, and you can pass in, it's optional. You can pass in standard, which I guess is the default that we have right now in Kelvin. We have metric and imperial. Now, I don't know about you guys and what measurements you use, but for me here, we're going to use metric. I think for you guys, if in the US, you're probably Fahrenheit, right? Units equal metric. So that's how you would just add another parameter here. You use the ampersand and then the parameter name followed by the value. So if we do that, that looks a little more like what I'd expect. Feels like, pressure. Now you can capture as much of this data as you want, and we'll take a look at how in a second in Xcode. But for now, let's go through the rest of this data. We also have hourly data, and you can see it's the same thing, but notice that for this, it's a square bracket instead of like a curly bracket, and this square bracket usually denotes like a list of items. Okay, so you can see here, there's actually 14 items. You can collapse them all, but each of these items inside this hourly list is a temperature with a certain time that is different from the current time. So this current is current temperature. This hourly is going to be the temperature for each hour. If we go back to the app challenge, the requirements for this app is going to be show current temperature, current feels like temperature, and general weather conditions. Be able to switch units from Celsius to Fahrenheit. So that's going to be, just making a call on metric or passing in imperial. Have an hourly temperature display for the next 12 hours. So what I typically do when I work with the brand new API is just try to get a valid response first, right? Try to make that request to this API, pass in all of the necessary parameters, have a positive response, like a successful status, and then try to parse some of the data. So the app requirements, there are a ton of different app requirements here, but I'm going to focus on just one very basic thing, which is show current temperature for Beirut. All right, so let's focus on that. We're going to jump into Xcode now, and we're going to set up our project, set up all the scaffolding and the foundation of it, and then we're going to try to make an API call here, and then we're going to try to just display the current temperature on the screen. Very basic. So think small first. Let's get rid of that. All right. Here comes the fun part. And this is where the M1 Mac will shine and not kill my stream when I try to build something. Okay, so we're going to create a brand new app here. Oh, I haven't even added my account yet. Yeah, this is so new. Weather app demo. Interface is SwiftUI, lifecycle is SwiftUI app, and language is Swift. We're not going to do core data or tests, so we're going to go click on next. And we're just going to save it on the desktop right there. So let me see if I can make this screen a little bigger. And the audio is good. You guys, there's some background music, but you guys can hear me fine. How difficult is it to convert those seconds to hours and minutes? Actually, really easy. So in the date class, you can create a date object, and you can pass in the seconds, and then you can use the date formatter class to specify whatever format you want. But usually I have to Google the format because it's like HH:MM, and then there's a bunch of letters to specify the format. So specify the format, and you can convert that date object to the format that you want. Okay, thank you for confirming. I know in the very first streams that I did, I had some issues with audio. Let me just make this a little bigger even. There we go. Wow, this is really big on my screen. Okay, so one of the things, if you go through my beginner lessons, you'll know that I like to separate things into groups, so it's especially for a beginner, it's easier to understand and see the different components working together. Oops. Oh man. Okay, so we'll move our content view, which is our base view, into our views group, and then we'll have this entry point at the top there. Let me see. Let's try compiling and running just this basic thing. And let's take a look at the stream for performance. Look how fast that was. All right. Okay. Now, oh yes, I said I was going to set up the scaffolding first, so let's go ahead and do that. Okay, so we're going to set up a view model, and the view model is going to supply all of the data for the view. So we're going to create a brand new Swift file here. Let's call it weather model. And we're going to make this an observable object, which means that our view will be able to observe changes to certain things inside this class. Because inside here, we're going to be fetching the data, we're going to bring it back, and as soon as that data comes back, we want the view to be to realize that, right, and to display that data. So that's why this protocol called observable object will help us with that. And then inside content view, what we can do in here is we can create a observed object, and this is going to be our weather model. So I'll just call it model, and we will create a new instance of weather model. Now inside the weather model, when this instance gets created, this initializer method will run, this basic default init method. See, when we create that here, it's going to be calling that. Now in here, just to test our API call, we can make the request to the API, right? We're going to parse the response. So when we make the request to the API, we're basically hitting this endpoint right here in the browser URL. And then the response that we get back is going to be this data right here that we just walked through. Now, we can't use the data in this format. This is called the JSON data format. We're going to need to turn this JSON data into usable instances of our models, which we haven't created yet. And so that's what parsing the response means. Parse the response into, I don't know, weather objects. We haven't created these weather objects yet, but we will define that inside models here. So it's going to represent the data that comes back from here, right? That's what our models are going to represent. We're modeling our data. And then we're going to set. I'm just thinking about how to explain this properly in case there's you know, someone who's just starting out in the chat right now. So I'm trying to think about the best way to explain this. Now I mentioned that when the response comes back and we parse it into these weather objects, we'd want the content view to be to pick up on that, right, and be notified. Well, the way you do that is you can create a property up here called published, and this can store your weather objects. So we might call it weather for lack of a better term right now. And this will be an instance of the model that we create in here. So right now I can't actually declare this yet. So let's just comment that out. But we're going to set the weather property with the parsed objects. And the fact that we have this property wrapper called published right here, as soon as we set our parsed objects from the API response, as soon as we set that into this property, because in the content view, which is what the user will see, because this is an observed object, it's going to pick up on that change, and we're going to be able to display the data inside our view here. So right now we just have a hello world. Okay, so let's go through the process of modeling our data. We're going to create a new Swift file in here in our model group, and we'll call this weather. I don't really have a good term for that, but if we take a look at our data now, essentially what we want to do is create some Swift structs that map to this data. And we don't have to map all of the data, because right now we're only interested in the current temperature. Like I said, we want to start really small, and we can add on pieces as we go on. Because, you know, if you model everything and you run into errors in parsing, then you've got way more to figure out and to troubleshoot. So I always like to start with like the smallest, easiest case and sort of build up from there. Okay, so this is the outer object that we're trying to map here. So maybe I'll call this weather response. All right, and we'll have properties here that represent, you know, the information that we want to capture here. So let's say we want to capture lat and long, and these are this would be a double data type. That's what we would represent here, lat, and this would be a double. This would be a double as well. But what we're really interested in, for the current temperature at least, is inside this current property right here, because inside here it's another object which has the date time and then also the temp. So this is the temperature that we're interested in, right? So we're gonna have to create var current. Now what's the data type for this? Like I said before, it is an object in itself. So we have to create another structure to map or model this data right here. All right, so let's call that an actual, let's call that the actual weather struct, because in my point of view, this outer object is just a wrapper for, you know, the actual weather data that we want, which is inside current. See, this is a, you know, a unit of weather, and this hourly is an array of these units of weather which have, you know, a particular timestamp to it. So if we take a look at what this unit of weather has, what we're most interested in right now is a date timestamp right there, and also the temperature. So both of these are doubles, let's say. So var dt temp, right? And we're matching the property names exactly to the key names here in the JSON data. And that's going to make it easier for us to parse. We don't have to do that. There are ways for you to specify coding keys to map your property names to the JSON key names, but let's keep it simple here. Now for current, we can say that this is an instance of weather. Here we're assuming a couple of things. We are assuming that there always will be a lat, long, and a current, because we have not made any of these optional. That means when it's parsing the response, it's going to look for these pieces of data. If, for example, the lat is missing or the long is missing, or sorry, not long, long, and current is missing, like this is just empty, then we will probably crash our app. So sometimes in the API, you'll be able to see if it can ever be nil or not. Like in this case, let me just see very quickly here. Yeah, here's lat, long, and current. It doesn't tell us if this could, for example, be missing information. I'm assuming it wouldn't be missing, and that's what we're going to go with. Okay, so the other thing that we have to do is to conform to this decodable protocol, and this is going to make it easy for us to turn this response data right here into instances of this. So let's go ahead and make the call. I realize that we're running out of time because I talk so much and I'm trying to go a little slower, so I'll pick it up a little bit. But we are going to try to parse this response into this weather response right here. So we're going to kick off the call right here, and we're going to do that with a class called URL session. So this is typically a little harder to understand for newcomers, but after you do this a couple of times, you sort of get used to it. So first of all, you get the shared session, and then you create a data task from it. So I'll show you what that means. Session.dataTask, and you can pass in either a URL request object or a URL object. Now, if you need to specify a more complicated request, maybe you need to put something in the headers or something like that, you would use this. But for our purposes, for this API, all you need to do is pass in the API key through this query string parameter. So we can go ahead and do it through a URL. Now, in addition to having these two options, there are also versions with a completion handler, and that's actually what we'll want, because this completion handler parameter lets us specify a block of code, also known as a closure, a block of code to run when the response comes back. So inside this completion handler, inside this block of code, that's when we are going to do this work right here. Parse the response into weather objects and then set the weather property with the parsed objects. All right, so this is the one we want. Okay, so first of all, we need to create that URL object. All right, so let URL equals URL, and there's one where we can just pass in a string, but if you notice this one, this potentially could be nil. So typically you'd want to check if this is nil or not before proceeding, but for the sake of time, I think I'm just going to throw all caution to the wind and just run with it. So we are going to create a URL object like that, and this is exactly the call that we made in the browser right here. I just copy and pasted it, so we should get the same response. So let's go ahead and do that. We're going to pass in that URL in here. We're going to force and wrap it. If it happens to be nil, this will crash. We're going to double click this closure to open up a block. Sorry, double click the parameter to open up a block of code or closure. We're going to give each of these parameter names. This is the data that is returned. This is the response if you want to check status code or anything like that. And this is any potential errors. So this is the data that we'll want to parse into weather objects. So let's give that a name, data, response, and error. And then what we'd actually want to do is in here. All right, so parse response into weather objects. Actually, one thing before we forget, and I always forget this, is when you create a data task from the session in here, it hasn't actually been fired. Like, you're not firing off that request yet. All you're doing is creating a data task that's ready to be fired, or you know, a request to be made. So you have to call the resume method on it. Now you can either call it directly from here if you don't need a reference to the data task, or you can assign this to a constant like that, and then you can call resume on your constant instead. So it really depends. Maybe you want to track the progress of it. If it's a download or something like that, then you'd want to keep a reference to it. Okay, so let's go ahead and parse these weather objects. So we're trying to parse this data that gets returned, right? And that data represents everything in here if it's a successful call. Maybe before we parse the data, we should see if we're able to make this call and what we get back. And this is a good opportunity for me to show you that network debugging. Now, I use this tool called Proxyman. There are a variety of different tools you can use out there, right? So I am going to, okay, so first of all, we have to launch this app, right? What's going to happen? It's going to show this view, which says hello world. It's going to create a weather model. And when this weather model object gets created, this init method is going to get called, and this is going to kick off that network request, right, to the API. And then we're going to see it show up in Proxyman. Proxyman essentially sits in between your app or in between your computer and, you know, wherever you're trying to make requests to, and then you can peek at the traffic. All right, so hello world. We see the screen. It should have got kicked off. Weather app demo. I'm just going to pin this to the top so we can see it. Now, initially, you won't be able to see anything in here. What we have to do is we actually have to enable we have to give security access for Proxyman to listen to that traffic so that we can see it. But we can see that it made this API call, and it returned with a status code of 200, which is successful. I wonder if I can make this bigger. Can I zoom this? Nope, I can't zoom it. Okay. What I'm going to do is install the certificate on my simulator so that we can actually take a peek. All right, so it makes it really easy. Okay, I'm gonna install it on my simulator now. Okay, and then I have to reboot my simulator, and that's it. So it's gonna crash this because it just killed the simulator, and then I'll launch this again. It's booting back up. Yeah, the app right now just says hello world. We're still testing out the network call, making sure we can make a successful network call, and making sure that we get back the data that we are expecting. So this is the call that just went out. Let me actually see. Do I have to enable this? Okay, let me just try to run that again. Okay, now we can see it. So this is the network call that just went out. You can see that, you know, it's the request goes to this URL. On the left-hand side here, you can see the request, you can see the body, you can see the raw request, and then the response is what we're interested in, the body here. Take a look. This, I know it's hard for you to see because the text is so small. Unfortunately, I can't enlarge this, but this data, this response that our app, this app is getting back is the same response in our browser window right here. So this tells us that we are indeed getting the appropriate data back. Now, a tool like this is really helpful sometimes because it's hard to see what's happening in terms of what the API is sending back to you. So if you ever run into issues where you need to debug network traffic, a tool like this is great. This is free. I mean, you can pay for it, but I'm using the free version, which is more than sufficient for what I need right now. Okay, so since now we have verified that we are making this call and we're getting an appropriate response back, we can try to parse it. So to parse it, we use a class called JSON decoder. And all we have to do is decoder.decode, and we are going to pass in the data that got returned from the call. This method throws errors potentially, so we need to be safer about it and wrap it in a, some error handling. In Swift, there's a do catch block, which I'll show you right now. Okay, so what we're trying to parse, we're trying to decode the data. So let's put this in here, and the data can be nil. Like, this is an optional parameter. So, ideally you'd want to check if let's do that. So ideally you'd want to say something like, if the data is not nil and the error is nil, that means that there's no error that came back and that there is data for you to parse. So normally you'd want to do this sort of check, right? And you'd only attempt to parse everything if this is true. Right. And then again, up here, you would definitely check if you were able to construct a URL object and not just force unwrap it like I've done here for the sake of time. Okay, so we've already checked that the data is not nil, so I can safely force unwrap this. And what are we trying to parse this data into? Well, that's where our models come in, right? We have mapped the data that we're interested in. We have mapped this response to this class here. So we're trying to turn this data that we get back, right, into an instance of weather response. So that's what we're going to put here. And in order to specify it as a class, we're going to put .self there, and we're going to try. So when this throws errors, we have to put the try keyword in front of it. We're going to try to parse this into, let's say, let weather equals that. We're going to try to parse the weather response into this weather constant. And then what we can do, now we can declare this published property up here. So we use the published property wrapper to indicate that when this property changes, the value in it changes, we want to notify anyone who's observing it. So this is going to be a data type of weather response, and we're going to make this optional. So this initially is nil because we don't have any data. And then down here, what we can do is we can set this property to the data that we parsed from the API. So we're going to say self dot, did I call it weather? I think I called it, yeah, weather, self dot weather equals, maybe we'll call this weather response just to be a little more clear. And we'll set it like that. Now what's going to happen is when you do this, because this property up here is a published property, it's going to cause the view code in here that depends on it to reevaluate and create new UI based off the fact that that has changed. So we always want to update the UI from the main thread, and how we're going to do that is with a class called dispatch queue, and this is how you would pass off a task or some code for the main thread to run. So we can put that in there. Update the UI from the main thread. Right, because setting this weather property is going to cause view code to reevaluate. Okay, so it looks like we still have some errors here. Invalid conversion. Okay, we didn't wrap this in error handling yet. Remember I said that this decode method could potentially throw errors. So here's what you would do. Catch, and you would put that inside the do, and in here, if there was an error from trying to parse this, it would come here and you can catch it and you can display it. But let's take a look at what's happening here. Oh, this should also be inside this do block. Okay, let's see, let's take a look. Did I do this wrong? Decoder.decode weather response.self. Give me a sec here. Struct weather response decodable. Oops. Oh, you know what? It might be because I have a couple of, there we go. It was confused as to which weather response. Was I referring to the class or the parameter? But I remember I wrote response as the parameter. I don't know. Did autocomplete change this to weather response for me? It might have. Okay, but in any case, our code should be pretty good now. Okay, so what we're going to see now is when we launch the app, it's going to make the network call, it's going to come back, and it's going to parse it, and then it's going to set this published property to our weather response. So let's step through this code by setting a breakpoint. Let's set a breakpoint right here when it kicks off the call, so you can see that, and then we'll set a breakpoint right here when the response comes back. We're doing okay for time. Okay, so initially we're going to kick off that network request. So I'm going to continue execution, right? Then it comes back with the response, and shut that off. No, we still have it. So I think this is the response that came back, right? So that's captured it here in this closure, and we can check, does the data actually contain data? Is there an error? If we're good to go, it's going to go into here. It's going to create the JSON decoder, and then we're going to try to parse that data into an instance of our weather response struct. So it looks like we're good, right? It didn't come in here. We should probably print the error there. But when it comes here, essentially we're setting the data to our published property, and it's going to pass that off to the main thread to do. Right. Okay, so right now, the last thing for us to do is to use the data that we have now and display something in the UI. So let's go ahead and do that. So here we can, because initially, remember that in weather model, this is nil, right? Model.weather is initially nil because the data hasn't come back yet. So before we display anything, we're going to check if model.weather is not nil, display the weather. Otherwise, whoops, where's my else? Otherwise, we can display a progress view component. Right, so when you launch it now, initially you're going to see a progress view, and then afterwards you're going to see, let's say, we're going to sub in, we can say if let weather equals model dot weather, and this is just another way of expressing checking if this is nil or not, right? So if this is nil, it's going to go down to progress view. If it's not nil, it's going to assign it to this constant called weather here. So here we can just do weather, and then we can display current. So current is a double Celsius. Okay, so now let's run it and see what we see. Oh, what have we got here? Append interpolation. Did I do something wrong here? Weather. Current is an object. Oh, yes. Sorry. Thank you, chat. Thank you. That's right. So current was the object, and temperature was the actual value that or property that we're trying to display. So we get something like that. Yes. I'm glad you guys are paying attention, because it looks like I'm not. Okay, weather in Beirut is 29.76 degrees Celsius. Now, we can round that if we want, but right now, let's try to display the hourly. Or let's try to round it. If this is a double, right? So what we can do, since we'll probably have to do this a couple of times, what we can do is create a function here to, let's say, how about temperature to string? And this is going to accept the temperature in double and give us a string back. So in here, we're going to say that I want to return string. So string has a format initializer where we can specify how many decimal places we want, and we can try to, I don't know if you could just pass a double in like that. So let's give that a try. temp to string. Hello from Egypt, Malaysia. Awesome. Yeah. He's watching someone code live. Yeah. How many of you guys are actually, like, this is completely easy in review for you? And how many of you guys don't know what's going on because you're so brand new to app development? It'd be nice to know, because then that would allow me to tailor what we work on. Okay, so we have about 10 minutes. Let me see if I can quickly parse the hourly weather and display it. So inside weather response, now that we want to capture, where's our, yeah, so we've captured current and we want to capture hourly. You can see hourly is an array. It is a list, essentially a list of weather objects. So what we're going to do is add to our weather response. So we want to capture hourly, and this is going to be an array of weather. Now, just by doing that, it's going to parse the hourly data now. So inside content view, we can actually display this in a list. We can try to display it in a list. And we can do something like hour temperature, and this would be, you know, hour dot, oh, we're gonna have to convert that actually. Yeah, hold on a second, because let's back up, because we are using we're trying to put this into a list component. We are going to make this we're going to make this identifiable, and we are going to add an ID parameter here. So this is going to be a UUID. Initially it's going to be nil, and then we're going to set this. So this is going to allow the list component to differentiate between the different hourly weather objects. So inside our weather model, when we parse it here, we can add UUIDs to the hourly weather objects. So we can say, you know, for I in 0 to weather response dot hourly dot count, we're going to say weather response dot hourly dot ID equals UUID. Create a new UUID for each hourly. All right, and we got to change that to var, and then that should allow us to use this in the list. And then in here, let's see, hour dot DT, which is basically just a double now, right? It's this. We're going to have to convert that to an actual hour, but let's just display it for now. And then this is going to be hour.temp, but we have a method here, temp to string, so we can use that. So let's display that. Yeah, this is awesome. We have currently 87 people in this stream. That's awesome. Thank you so much for all of your support and for watching. Okay, so we have that initial text up here, weather in Beirut. We have the temperature, and then we have the hours. So as you can see here, it's just a long number because that's what we got back here. We're gonna have to convert that. Where's our simulator? But you can see the temperature differs from hour to hour, so this is great. So let's go ahead and convert this hour into like an actual hour, and then I'm gonna have to unfortunately end the stream, and then we'll continue building the UI. We'll refine the UI in the next stream, because for right now we have accomplished quite a bit, which is to be able to connect to the API and fetch the data and then be able to parse it and display something on the screen. Okay, so let's create another function down here called seconds to hour. That's not the right thing to call. You guys have any suggestions? All right, seconds to hours it is for now, and then you guys can decide. Here we're gonna pass in the Unix number of seconds. I believe that was what it was. Current time Unix. So let's just say, and we're gonna pass back a string for display. So we're gonna say let date equals date, and before in the past when I'd done this, I wasn't sure which one to use, but sometimes you just have to play around with it and see which method to use. But in this case, I'm gonna believe that it's this one. And then we're gonna create a date formatter. And for the date formatter, we're going to set the date format to, I'm gonna guess here, because is it capital M's? I always forget. Let's go with that for now. And then we are going to say date formatter, date from string from date. Yeah, so this is gonna allow us to pass in a date, which we have right here, and it's gonna return us a string in the format that we've specified. All right, so we're gonna pass in our date, and this is what we're gonna return. All right, source date, desired format. All right, so let's give that a try. Seconds, did you guys have time interval since reference date to hours? You know what? That was probably a joke, but I'm gonna use that. This is not good, by the way. Let's not have super long method names like that. Oh, I can't even, it's way too long. Okay, and we'll make this argument label optional like that. Is this right? And a state formatter. And that's what we want. That looks good. MS month, yeah, you're probably right. I always forget these formats. Luckily, we have handy references like this. You're right. There, MM. Where are we here? All right, cool. It doesn't look like much, but this challenge, the hardest part was really to interface with the API and download the data. Now, a lot of you guys did wonderful UIs. If you want to check it out, definitely go, let's see, I want to play all of it, but let's see, here it is. Wait, no, this one. I'm just going to put this in here in the chat. If you guys want to take a look at the community weather apps that other people have built inside our Code Crew community, and if you want, here in the chat, I'm going to post the challenge, the community app challenge for this weather app if you want to try it yourself. And then in the next stream, we are going to refine the UI, because right now I would be kind of embarrassed to say like this is the completed weather app, especially if you guys take a look at that video which I pasted. Has a lot of wonderful, awesome weather apps. Now, before we end off the stream, I do want to highlight your attention to a sale that's going on from Mark Moikins, whom I really respect as a teacher, and I use his resources myself. So I've used his resources to learn Combine, which I haven't completely gone through the whole thing yet. I'm still in the process of learning. But the SwiftUI Views Mastery is a great reference book, especially when I'm coding, because it lists all of the UI components and their behaviors, and there's like sample code that you can copy and paste very easily. So it's not a dense textbook, and that's not the way it's intended to be used. It's a visual reference, which means that you can search for the component that you need, either like copy a code snippet or to read up on its behavior and properties. Because, for example, some SwiftUI views expand to take up all its available space, and some SwiftUI views sort of take up as little space as needed for that component. So sometimes, to remind yourself, it's really useful to have a reference like that. If I'm a beginner, what course do you recommend I buy from you? If you're a beginner, you actually don't have to buy anything right now. To get your feet wet, just go to codewithchris.com/start. And I would recommend that you start with a 14-day beginner challenge. Get your feet wet. You're going to learn the basics of some Swift logic and some Swift code, how to construct UIs, how to navigate around in Xcode, all for free. So if you find that you enjoyed the experience and you like app development, then go and invest in a course or something like that. So I'll paste this link here as well. Scott, the stream will be reposted. I think as soon as I end the stream, the replay is just going to be live already. It's not going to be unlisted or anything like that. All right, awesome. So unfortunately, I have to go lunch with the fam, but thank you so many people for joining. I do notice that you guys love coding, and now that I have this new M1 Mac, we'll do more of it on stream. So again, thank you guys so much, and I'll see you guys next time, probably next Tuesday. Check cwc.to/streams to find the schedule. Right now, I don't have anything scheduled, but I will put one in definitely for next Tuesday, same time. All right, see you guys later, and thanks for watching.